Hi everyone. So today we are discussing physical world part 3. Okay, already we are discussing part 1 and part 2, introduction of the physics and scope and excitement of the physics. Already scope and technology of the physics already we are discussing. So today we are discussing a part 3 video. Okay, this is also very useful who comes from the 11th students. Okay, please utilize this opportunity. Okay, so we are going with our topic. Okay, next continuation topic. Part 2, then part 3 continuation topic is the next topic is the excitement of physics. Okay, so physics is a natural philosophy, already I said. Okay, so how to excite the physics? So excitement, we are learning in physics, we have very curiosity. We have more excitement. So because of physics is giving the new technology and sometimes technology gives the new physics. So how we can get the excitement means here. So few basic concepts and laws can explain many phenomena. So I explain one example here. The basic example is the Newton third law. So this is a wonderful experiment. Is it right? So Newton third law. Okay. So who is studying newly in physics? So this law we know means that persons are very excited. So Newton third law is a very enormous expression, very excitement of the physics. So because of when how much we are applying the force, same amount of force is applying the opposite side. So again it's a universal gravitational law. So that is also wonderful law. Okay, and next one is a universal gas constant R. Okay, the gas constant value is applicable for the all values. So that is also very excitement of the physics. So like this many laws is there. Lenz law is a very good application in physics. And Faraday's law, Ampere's law, okay, Coulomb's law in electrostatics, that is also very wonderful experiment, Coulomb's law. Okay, and Rutherford gold foil experiment. Okay, so laser beam is hitting on only nucleus particles only. So very exciting in that experiment. So because of in the atom 90% is free, only one single ray is hitting to the that alpha particle nuclei. So that particle only coming outside the gold foil. Okay, that is also very good experiment only. So we are exciting, we are feel excited. So that's why physics is giving the excitement. Okay, two basic concepts and laws can explain the many phenomena. So many phenomena. Galileo phenomena. What is phenomena? So he is researching about the laws of motions. Okay, he is some phenomena is given. Okay, Einstein's phenomena and Albert Einstein's phenomena. Okay, he is also giving them some motion of the laws, motional laws, and Ptolemy is giving some phenomena. Okay, that phenomena is also very excited only. These all phenomena are giving the excitement of the physics. And next second one is the applicable in your daily life. Yes, each and every work is the physics I said. Now I am speaking with you. You are hearing my voice because of I am applying the physics here. Okay, we are lifting the some weight. So how much I am applying force, same amount of force is acting in downward also. So again, each and every work you can apply the physics, you are feeling more excitement. So we are traveling in a car, so because of friction, you can apply physics there also. Okay, so again we are feeling the excitement only. Okay, physics you can apply in each and every work, each and every minute, each and every second. Okay, you are feeling more excitement. And next way, prediction of the future events. Okay, nowadays we don't know any place also, simply we are using Android mobile, simply we can search the Google Maps. So our location to our destination point we can searching, simply we can go through the Google Maps. So that is the future physics. So that is also one of the excitement. So easily in our place, so how much traffic, how it is there. Okay, so in that place is forest, main highways or small roads, different we are observing. No, so three-dimensional Google Maps also available. Okay, that route path how it is also easily we can observing with the help of the Google Maps. That is also very wonderful excitement of the physics. Okay, so excitement of the physics, each and every second we are exciting on physics because of we are the physics students. Okay, so we know the physics value, that's why we are exciting the physics. Okay, everywhere is the physics is applicable, in the total universe is physics is applicable. So that's why I am feeling more excitement of the physics. And next one is the next topic is physics and technology and society. So sometimes physics is giving the technology, sometimes technology is giving the physics. So physics gives to technology, or technology gives physics, whatever it may be. These two are helpful for the society. Okay, so physics giving technology, or technology giving the physics, whatever it may be. These two applications are very useful for the society. Okay, nowadays, so 1 hour current off also we are not sustainable in that place. Is it right? So because where modern days we are living here. Okay, so how we can produce the electric current? In olden days we are using the steam engines. So then after day by day science also developed, science also growing up. Then after we are using the nuclear reactors. So that nuclear reactors we are producing the very large amount of electric current in future. So that is only main source of the electric current. And solar energy, that is not ending. So that is a future energy. So means technology is giving here physics. So some examples I explain over here. So one more example. In olden days, 1870, 18th century and 19th century, so we are traveling in trains. Okay, the trains are very horrible sound, very noise is creating because we are using the steam engines. But nowadays we are sitting inside the train, but we are not hearing the small noise also. Okay, because of technology is very highly developed. Okay, steam engine's case, what is the law? The steam engine is working under the heat only now. So that is we are studying in thermodynamics. So physics is giving the heat, means thermodynamics. Okay, with the help of this thermodynamics, improving the efficiency of heat engine. So we can improving the heat engine, steam engine again we can improve, we can modifying that engine, we are producing the electrical engine. That electrical engine also some amount of heat produced. Okay, electrical engine, so that is gives the industrial revolution. So granites case also we are using industrial revolution, means not only granites, everything, each and every case. So we are using the electric current, thermal current, water current, okay, nuclear current. So that is giving the industrial revolution nowadays. So very key role is playing in Indian economy, industrial revolution. Okay, and next one is the technology gives the rise to a new physics. Technology is giving the new physics. How to give the technology giving new physics? Means, so improving, we are improving the steam engine. Steam engine we are improving. So let's study the physics in thermodynamics. Okay, steam engine we are improving. What we are making among electrical engines. Okay, electrical engines we are making no. So comparing to the steam engine, electrical engine efficiency is very high. That electrical engine is going very high velocity. So steam engine using case 100 kilometers distance we are reaching in 4 to 5 hours. Nowadays that 100 kilometers distance we are reaching within 1 hour with the help of the new physics. Means electric engines. Okay, so and one more example also explain what is that. Physics gives rise to the new physics. Here technology is giving the new physics. Now physics is giving the physics gives the new physics. So what is that? Silicon chip. Okay, silicon chip means conductors. That is also again physics only. That conductors again we are remodifying first generation computers, second generation computers, third generation computers, fourth generation computers, and future. So we are using semiconductors. So first generation computers case we are using vacuum tubes. Okay, so in that case computer size is one room, very big size. But present days computer within our hand only we are using mobile, best example. So again remodifying the size. So with the place of the vacuum tubes we are using transistors, okay, microchips. Now we are using semiconductors, computer revolution. Okay, 4 generations we can modify. No, generation to generation computer size will be decreased. Okay, easily. So we can bring to the one place to the another place. So computer revolution, that computer revolution only. So very important. So physics is giving here new physics only, no. So computer revolution is completely new physics in modern days. Okay, so there we are using the silicon chips means semiconductors. Okay, so that semiconductors are the modern physics, new physics. And one more application, electromagnetic waves. So present days satellites and weather forecasting with the help of the satellites. Okay, so cyclones and tufans and rainy season, when coming to the rainy season, tufans and cyclones. Okay, tsunami. So weather forecasting, all weather forecasting, and any dramatical change in the universe easily we can observe with the help of the satellites. So in Earth surface to the satellite is launching in above the Earth surface 36,000 kilometers and 40,000 kilometers, 1 lakh kilometers. So we are connecting any wire, we are not connecting any wire. So but we are communicating with the satellite. How we can communicating with the satellite? So wireless communication. So that wireless communication with the help of the electromagnetic waves. Okay, so now I am talking with you because of electromagnetic waves. Okay, now so that electromagnetic waves is giving the wireless communication. Okay, we are using mobile, so because of electromagnetic waves, that electromagnetic waves only transferring the sound waves. So electromagnetic waves are receiving to the receiver, that receiver converting the sound waves via audible our voice. Okay, so this is the part 4. So excitement of physics, technology and society. Okay now, and next one, so we are discussing the basic forces in nature. Basic forces in nature. So what are the basic forces in nature? Many different forces is there, but in that forces only we are discussing only 4 forces only we are discussing. Okay, muscular force, okay, and gravitational force, mechanical force, electrical force, okay, and pulling force, pushing force. Okay, many different forces is there. Nuclear force, okay, and spring force. Okay, so like this many number of forces is there, but we are not discussing the forces. So conclusion of this chapter, last topic is the basic forces in nature. Okay, basic forces in nature. So how many basic forces is there in nature? 4 basic forces. So first one is the gravitational force. Okay, and the second one is electromagnetic force. And third one is weak nuclear force. Third one is weak nuclear force, and fourth one is strong nuclear force. Strong nuclear force. So one by one we are detail explain here. First one is the gravitational force. Okay, so I am starting in floor now. What is the reason? Because of gravitational force. Okay, any object is placing on the surface of the earth because of gravitational force on the earth. What is the gravitational force on the earth? So this is the standard value. Gravitational force on earth is so you know very well this value 9.8 meter per second square. So 9.8 meter per second square is the SI units. But what about CGS units? Gravitational force value. So in CGS units, gravitational value is G is equal 980 centimeter per second square, because 1 meter is equal to 100 centimeters. 100 into 9.8, 980 centimeter per second square. Okay, so gravitation on the earth is 9.8 meter per second square. So like this, I am discussing about the earth. So earth gravitation is different, 9.8, approximately we are taking 10. Now, so for suppose earth subplanet is moon. Okay, so moon gravitation is a different, moon radius is different. Okay, moon gravitation is 1/6th part of the earth. Mars gravitation is different, sun gravitation is different, Mercury gravitation is different. So different planets, different gravitational values, and okay, and different radiuses having the particular planets. Okay, so gravitational force is 9.8 meter per second square, but gravitational force is a very weak force. Okay, this is very weak force, and gravitational force is a long range force. Okay, long range force, very weak force and long range force. Okay, so long range force, very weak force. We are not feeling gravitational force, but we are standing on surface. Okay, this is up to nearly 36,000 kilometers from the earth center to the above the surface. 36,000 kilometers is applying on gravitational surface on the earth. Okay, so up to 36,000 kilometers earth gravitational field is acting only. After crossing 36,000 kilometers, earth gravitation is not acting. Body does not coming to the earth surface. Body is escaping from the other planets. Okay, and that range is no need that value. That weak range force is approximately equal to the 10 power minus 1. Simply 10. 10 means this one. Okay, so this is the gravitational force. How to apply the gravitational force? Gravitational force is applying on any two bodies. First body is earth surface, second body. For suppose I am standing here, human body. For suppose I am taking this marker. So this marker mass m1, earth mass m2. So gravitational force is always acting in between two bodies, not single body. Okay, gravitational force is always attractive force. Gravitational force is always attractive force. Always attractive force. Okay, so gravitational force is a attractive force. Okay, and gravitational force is acting in between two bodies. Don't forget, these are the two very important points. Okay, and gravitational force is existing in nature. gravitational force is existing in nature. Okay, that gravitational force no need to medium. Without medium, with medium also gravitational force is acting. Okay na? So this is about the gravitational force. And next one is, what is that next one? Electromagnetic force. This electromagnetic force is applicable on charged particles. Okay, so this electromagnetic force is applicable on charged particles. Okay, electron, proton. Okay, charged particles only charged particles only electromagnetic force is applied. So electromagnetic force is a long range force. So this is also long range force, and electromagnetic force is a very strong force, not weak force. Gravitational force is weak force but long range, but electromagnetic force is very strong force and long range force. Okay, so gravitational force is acting between charged particles only. Okay, electromagnetic force, electromagnetic waves are passing through the equal to light velocity. Equal to light velocity. Electromagnetic waves are passing in the medium equal to light velocity. Electromagnetic waves also no need medium. So with medium, without medium, electromagnetic waves are passing. Okay, no need medium. Okay now, and electromagnetic waves are passing through the equal to the light velocity. Okay, this is a small information about the electromagnetic waves. And next one is the third force. That force is the weak nuclear force. So weak nuclear force, this force is acting in between the microparticles. Okay, acting in between the microparticles means atoms. Okay, already said weak nuclear force and strong nuclear force we are using in the nuclear reactor, means nucleons. Inside the nuclei, atoms having. Okay now, so positive and one positive and one negative is the nuclei. One positive ion and one negative is the nuclei. Is it right? So microparticle that is acting between the atoms. So weak nuclear force. Gravitational force range, how much I said? 10 power 1. Electromagnetic force range is 10 power 36. Okay, and weak nuclear force range is 10 power 32. Okay, 10 power 32. So this is short range force. So this is the very short range force. Okay, this is one atom. Here only nucleus particles have it. So this nucleus to this nucleus, very short range. That short range value is the up to 10 power minus 14 meters. After crossing the 10 power minus 14 meters, nuclear force is weak. Nuclear force is not acting. Okay, only alpha particles case only this is applicable. And so weak nuclear force is a short range force. Okay now, and next final one, strong nuclear force. So this is also acting between microparticles only. So this is also acting between microparticles only. But so strong nuclear force range is 10 power 38 meters. So this is also short range force. Okay, this is also short range force. So this is the basic nature of the forces. Okay, so please any doubt means comment on in comment box. Okay now, so please subscribe my channel and like the bell symbol.